The elements, a visual exploration of every atom in the universe. We are starting off with sodium. We know this as part of the elements that help us create our table salt. Very tasty, very salty, and really, really good at flavoring really bland things, such as unsalted meat or unfried chicken. You really need salt for that. It is included in our long list of alkali metals where it's really, really fun to throw into water, with the exception of, for some reason, lithium. Once you throw sodium into it, and this is practically very, very fun to throw into water from what I hear, it will explode. And it will either melt your eyes off if you didn't do the correct protection, or it will just give you a really brilliant firework-like, but more like waterwork-like effect. It's like a firework, but with water. According to the offer, apparently you can just buy these at camping stores and then just throw them into the river for fun. Or, in the case of magnesium, you can just scrape some off and then use it to light your fire. The offer even calls this the best tasting, mainly because of the salt, I'm guessing. Explosive as it is, because it generates all that hydrogen gas really rapidly. It practically just melts into the hydrogen gas, and that's technically evaporation, but I'm using the word melt here because it just turns into water, and then it goes into hydrogen gas within the water. Regardless though, it creates the most attractive explosion according to the author, which I am guessing he has tried himself. Of course, I eat sodium every day. It's just that I eat poisonous sodium. If you get my reference, you'll see what I meant later. Or you'll have to watch another video. Its atomic weight is 22.989770, which is about 23. Density is 0.968. The atomic radius is 1.90 picometers, and the crystal structure is cubic. Note, if I say this part wrong, picometers, please correct me. The atomic emission spectrum is kind of blue, and its electrofiling order is just increasing. Mostly it's found as a gas, but it's also found as a liquid, but you can also find it as a solid. Next, we have magnesium. Now, magnesium itself is not named after magnets. It's also not named after magnesia, which I just found out yesterday was a real place from ancient Greece. It's one of the first and truly marvelous structural metals. Beryllium itself, it's a fine metal, but it's too costly. As well as being a poison, so I don't think beryllium will be used in any practical applications anytime soon. Magnesium itself is moderately priced, and it's about as strong and light and easy to machine about. You can like put in a machine. About the only one downside is that it's really flammable. Magnesium itself is so flammable that you can just rip a ribbon of it with a match, and then fine powders of it are also really explosive. Because of its explosive nature and flammable material, it's probably not going to be really used in flammable dances. Here's another fun fact. In the early days of cameras, when they didn't look like that, and when they looked like this with a very big flashlight bulb to indicate that, well, it has been taken photo, it was essentially just lighting a piece of magnesium. If it's so flammable, why do we use it to make car parts? Who knows? But when we put the brakes in, and it prevents the heat from going to the magnesium, keeping it safe from fire. In fact, there are some parts of the car that prevents the heat from traveling towards the magnesium. It just sends it towards other parts, such as the tire, which is made of rubber apparently, and you can go ahead and make sure that the magnesium does not burn off your car. Yeah. This is kind of one of the reasons why it's used in campfire lighting matches. Its atomic weight is 24.3050, its density is 1.738, its atomic radius is 145 picometers, and it has a structural crystal-like thing. It has an evenly balanced atomic emission spectrum from my perspective. I'm probably not using these terms correctly, so thank God that I at least understand kind of what they mean. We also have an electron filling order. It's just starting to go up, and it's mostly found as a gas, but it can also be found as a solid or a liquid. Aluminum, number 13. It's closest thing we have to an ideal metal. Ideal metal will be the best malleable, the strongest, but can also be used as a actual strong thing. However, it can be improved in a few ways according to the book. It could be as cheap and easy to weld as iron. It's not that easy to weld. In fact, it's also kinda expensive. It should be able to be casted as well as copper and zinc. What do you think the author did when he was a kid? But overall, it should be very fine stuff. It should be light and strong enough to form the structure of that metal really well. Aluminum itself is a great metal. In fact, that's kind of why we use tin foil. We use aluminum foil instead of what we so-called tin foil. Also, most tin foil is still made from tin foil. It's usually made from aluminum nowadays. Its signature advantage over steel, though, is that it doesn't rust. Unfortunately, though, it does react really well with other things. Deep down, aluminum is really very reactive. Powdered aluminum is a basic ingredient in the modern-day flash powder and rocket fuel mixtures. Its sale is below a certain particle size. That's kind of restricted for a reason. Aluminum minerals are extremely common, including like the corundum, which is the generic form of ruby and sapphire, and beryl, the generic form of the emerald and the aquamarine, according to the book. This is an adaptation of the book, after all. Aluminum in minerals and rocks makes up a large part of the crust of the earth, which is why this aluminum piece of metal here, it's interesting to me, at least. I like my aluminum, thank you very much. And then we have to go ahead and talk to its neighbor, silicon. Before that, though, aluminum's atomic weight, 26.981538, which is around 27. The density is 2.7. The atomic radius is 118 picometers. And then the crystal structure is a cube. For some reason, its atomic emission spectrum, it's balanced but very low. It has a little higher electron filing order, and it's mostly found as a gas, surprising. But it's also found as a liquid, also surprising. And it's also found as a solid. The surprising part is that it's so small part of the spectrum. At least that's the part surprising to me. Oh, and here's an example of aluminum. Special examples. This is a charging hourglass dodecahedron rendered in rings of alloy aluminum. Wish someone would give me something like that. Next up, we have silicon, the other element of life. At least the potential element of life we have so far to see silicon-based life forms. There have been, however, a speculation in science fiction, and I'm pretty sure that silicon-based life forms will not be aliens, but will be AI, because AI needs silicon to run itself. Wow. Anyways, back to this point. Silicon itself is used in the technology sector. My dad works with this because he's in the technology sector. By now, it kind of seems like when silicon-based life emerges, it will not be on this planet, at least in my speculation. There will be at least one that will be silicon-based life. There are several things that can happen towards it. Large silicon crystal bowels are rejected for chip making, and some people actually go ahead and use this for casting and making, Mostly, we use this to create microchips, mainly because they are really good semiconductors. You don't want a really good conductor, but you don't want an insulator. What you need is something in between, a semiconductor. Why do you not want to use something like, say, iron as a conductor or copper? Well, those are good when you need to transfer hundreds of volts. No, not even hundreds of volts. Thousands and millions of volts at a time. But, yeah, a laptop needs something that can take less of that. It can take thousands of volts at a time, but that's exactly not what we need. Silicon is able to take it moderately, and it won't overheat too. All those iron stuff all that heat that the iron or copper wires would generate, it would melt a laptop. But silicon, it won't overheat. In fact, it will take it moderately, and it won't kill your laptop, and will give you enough time to be actually able to use this thing for several years. Most of the earth, the rock, the sand, the clay, and the soil consist of silicon, mostly that is, and with smaller amounts of aluminum and calcium and other materials inside there as well too. But the only thing that doesn't have a lot of silicon is the human body. While some sea sponges actually grow a lot of silica glass, your bones, assuming you are not a sea sponge, mainly use calcium. Its atomic weight is 28.855, its density is 2.33, and its atomic radius is 111 picometers. Its crystal structure is a cube, and it has, at least a higher amount of atomic emissions in the spectrum. It has a higher electron filing order, slightly, I'm guessing. Yep, ever so slightly. And it's mostly found as a gas. Interesting, I didn't know that myself. It also has a liquid, and mostly it's a solid form. Next, we have phosphorus. Phosphorus, this red, deep material. Phosphorus itself, in its elemental form, it's really nasty stuff, particularly the white phosphorus. It's very poisonous, and it has been used itself for wars and for killing people. Its white version will go ahead and is used for lighting matches. The red version, you just go ahead and use it for strike and matches. In the form of phosphates, compounds containing this thing called the PO3 negative group. Not sure how you say that in scientific terms. They were always like that. Phosphorus, when it was back in the day used for matches, you go ahead and you could create yourself your own phosphorus matches, and then you just light them anywhere, and then you just light yourself a campfire. Black phosphorus is the most stable form of phosphorus, but it is rarely seen. Red phosphorus is the most common form, and we use it a lot. Its atomic weight is 30.973761, its density is 1.823, its atomic radius is 98 picometers, and its crystal structure, it's a oblong cuboid. It has a moderate amount of emissions in the atomic emission spectrum, but I don't think there is any blue in there. It has ever so slightly higher electron filing order, and it's mostly found as a gas, with sometimes being solid, and the least amount of it not naturally existing in nature is a liquid. I didn't even know phosphorus could be a gas. And so that's it, my friends. That is the end of today's exploration of the elements. I hope to see you guys soon. Until next time, shut up, peace. Bye-bye!